Okay, so let's continue our contra-free exercises with the third exercise, which is about Capital One SSRF. Just click this one, and so we have about 17 steps to follow. Start with the background. Step number 1. The following interactive tutorial is a reconstruction of Capital One's data breach incident that exposed the record of almost 106 million customers. And Paige Thompson is accused of breaking into the Capital One server and gaining access to 140,000 social security numbers, 1 million Canadian social insurance numbers, and 80,000 bank account numbers. So that's actually the story. So let's get ready. And in step 2 here, we'll be checking the vulnerability. Based on the report by Krebs on security, the attacker exploited a server-side request forgery, or known as SSRF vulnerability, to access AWS cloud endpoints, the Amazon Web Services cloud endpoints. And these vulnerabilities are most commonly encountered in functional associated with, for example, here PDF generation, to generate PDF report of the credit card statement, file upload, such as uploading scanned document images, files, and so on. So here the attacker, which is Bob, begins by loading the Capital 10 website in his browser. Let's just copy this and put it into our simulated browser, capital10.com. This is actually almost just the example that will represent Capital One. Press enter, and in step number 3 here, Bob as the attacker will be logging or trying to log on as himself. Definitely you will need to register the banking account and proceed with logging. So let's just copy this to log on. So the username and the password will be copied, and just go ahead and select sign in. Now notice that once Bob has been successfully logged on, step number 4, attack surface will map the process of analyzing application core functionality, business logic, and control flow to identify potential inputs or factors. So having successfully login, Bobs will begin his analysis by browsing Capital 10 website, mapping the application key features and services. So let's just go to the website and select more account services. Okay. And in step number 5, we have changed card image. In the account services page, Bob notices that changed card image service allows the user to personalize their debit card. So let's have a look at this one. So change card image. So we got this activate card, change card image. Here we are presented by the Card Design Studio, which allows us to upload image, as you can see in step number 6. In order to customize credit Card Design Studio applet allows the user to upload this user supplied image. And of course, Bob here will decide to try this feature by using the following image. Okay, so click Browse to select. Or you can just drag and drop, right? So Bob is trying to upload the image called mountain.png, and it needs to select upload and preview. And in step number 7, preview image, notice that the image has been successfully uploaded, and Bob can actually see the Cart Design Studio preview showing the mountain, right? So further on, Bob will analyze the preview widget URL. As you can see on top here, the HTTP CapitalOne blah blah blah, the preview, and the URL that refers to the JPEG that has been uploaded. Let's click next. So the server-side request forgery can be found here. It is actually marked or highlighted. Having analyzed the preview URL and cart builder functionality, Bob attempts to modify the original URL by replacing the AWS S3 bucket link with the following URL. So this is actually the server-side request forgery step 8. So it's just copy this and then highlight and then paste, changing this to something else. Okay, so Bob here is trying to replace the AWS S3 URL with the Bob link. Let's copy again. Yeah, let's just delete this and paste and press enter. And notice that he was actually able to, or we are, as Bob, we are actually able to change the URL, yeah, to something else, which is the AWS S3 bucket. And remember that the ability to manipulate a web application into sending unauthorized requests to a third-party site is, or resource, is known as server-side request forgery, which means that we can actually change the URL to something else. Yeah. So it is important to note that the Capital-10 application server made the HTTP request to fetch the image URL and rendered the image. Let's move on to the next one. Now let's have a look at the backend code. Step 10, analyze the code. Document preview method is used for rendering the image, and then this method extracts the pre-signed S3 bucket URL, pass via the URL equal parameter and assign it to the query string variable. And then the parameter query string is then passed as an argument to the storage service.load method, which is responsible for downloading the preview image from the S3 bucket. And then finally, the load method invokes Java HTTP GET function to retrieve the image file. Unfortunately, no input validation check are being performed on the request parameter URL, which means that someone, like here, Bob, can control the loading of any arbitrary URL via HTTP GET. So the attacker can change to any URL that he wants. That's actually the source of the problem. Now, let's move on to step number 11, AWS metadata endpoint. Now, it says that although the server-side request forgery issues may appear to pose a limited risk, the attacker can get creative with these vulnerabilities to make requests to non-public URL that may expose sensitive data. Now, let's try to do this one, as Bob attempts to gain access to the Capital-10's metadata endpoint by submitting the following URL. So same thing, we can just change the URL, yep, to something else that we want and press enter. And success. By passing the URL metadata URL as an argument to the URL parameter URL, Bob manages to retrieve all categories of the instance metadata associated with Capital 10 web browser. Let's have a look at the next step. Now, listing the IAM roles. IAM stands for the Identity and Access Management role. Bob will proceed with enumerating the role that may be configured for Capital 10 web server by making the following requests to the security credential endpoint. Let's copy this and put it into our URL parameter and press enter. And this time the metadata request made by Bob returns a single role as the ISRM WAF role, which is associated with the server instance. And then step number 15, stealing the IAM role credential. Having identified with the ISRM WAF role, Bob will construct the following query to download access token associated with the ISRM WAF role. Let's copy this and change the URL parameter as usual and press enter. As expected, in step 16 here, Bob modified query to security credential and points and return the access key ID and secret access key token of the Capital 10 EC2 instance. Now, using the above access, Bob can now begin making some programmatic calls to the API with the privilege of the ISRM WAF role. Let's click next. The last step here is the console. Step 17. Bob will open a local terminal and configure the stolen AWS ISRM WAF role token on his laptop. Let's check or copy this command, AWS S3LS, and press enter. All right. Now let's click next, and that's it. So in fact, the main problem with this vulnerability was actually the ability of the attacker to actually change the URL parameter in the request. That would allow the attacker to steal credential of the intended, server, or from the intended server. All right, that's the last exercise, because we have only 3 exercises powered by Contra Web Application Security Training. I hope you enjoyed the session, and I hope that you can actually learn a lot from the application security training provided by this Contra. So I would personally suggest that you learn application security by looking at Contra as your platform. Of course, you can use a different platform to actually learn about application security, web application security, or even like the mobile application security. Okay, so see you next time in our next subject. Bye-bye.